The Hourglass Galaxy, formerly known as ESO 593-8, is one of the most strikingly beautiful and enigmatic objects in the observable universe. Located about 500 million light-years away in the constellation Telescopium, this galaxy owes its nickname to its extraordinary shape, two vast lobes of stars, gas, and dust stretching outward from a narrow, luminous waist, creating the unmistakable outline of an hourglass. What makes this galaxy particularly fascinating is that its shape is not a quiet, stable feature, but the result of a dramatic collision between two galaxies, whose gravitational dance has sculpted this cosmic masterpiece. When two galaxies collide, they do not crash like solid objects. Instead, their vast clouds of gas, dust, and billions of stars pass through each other, while gravity reshapes both systems. In the case of the Hourglass Galaxy, the collision appears to have set off massive waves of star formation. The blue glow visible in telescopic images comes from young, massive stars that have ignited in turbulent pockets of gas, while the reddish hues reveal older stellar populations and rich dust lanes. These colors, captured in spectacular detail by the Hubble Space Telescope, tell a story of cosmic upheaval, creation, and transformation. At the center of the Hourglass Galaxy, the two merging galactic cores are believed to harbor supermassive black holes. As the merger progresses over millions of years, these black holes may eventually spiral inward and collide, releasing unimaginable amounts of energy in the form of gravitational waves. This is not merely a violent event, it's a key process in the evolution of galaxies, shaping their morphology, triggering starbursts, and redistributing mass and angular momentum across scales of tens of thousands of light-years. What adds to the Hourglass Galaxy's allure is its temporal symbolism. Galaxies live for billions of years, yet here we witness a fleeting moment, an instant, astronomically speaking, caught in the middle of a transformation. It reminds astronomers and dreamers alike that the cosmos is not static, it's a vast theater of change, where destruction and creation coexist. The hourglass shape itself seems to whisper of time, a reminder that even cosmic giants are subject to the relentless flow of change and evolution. Observing ESO 593-8 also gives scientists critical insights into the physics of galactic interactions. By studying the dynamics of its stars, gas clouds, and dark matter halo, astronomers refine their models of how galaxies grow, how spiral arms are reshaped, and how central black holes influence their environments. Computer simulations run alongside observations, helping to reconstruct the past and predict the future of this cosmic merger. With every pixel of observation, scientists gather clues about the invisible scaffolding of dark matter that holds galaxies together and governs their fates. From a philosophical perspective, the Hourglass Galaxy invites us to reflect on scale and impermanence. While the sight of two galaxies merging may seem far removed from our everyday lives, it speaks to the universality of change and the interconnectedness of all matter. The atoms in our bodies were forged in ancient stars, perhaps in galaxies like this one, and the light we see from the Hourglass Galaxy today began its journey long before Earth was home to complex life. To look upon ESO 593-8 is, in a sense, to look back in time, not only to the moment of collision, but to the primordial processes that set the universe in motion. As we peer deeper into the structure of the Hourglass Galaxy, we uncover a cosmic laboratory where the fundamental forces of nature play out on an immense stage. Gravitational interactions pull tidal streams of stars into delicate arcs, some extending tens of thousands of light-years from the core, while shock waves race through vast clouds of gas, compressing them into dense knots where new stars are born. These regions blaze brilliantly in ultraviolet and X-ray light, signaling intense starburst activity and the birth of massive, short-lived stars destined to end their lives as supernovae. The chaotic beauty of this galaxy also holds clues to the distribution of dark matter. Though invisible, dark matter's gravitational influence can be mapped by tracking how the stars and gas move within and around the merging galaxies. Simulations suggest that during such mergers, dark matter halos, the immense, unseen cocoons surrounding galaxies, interact and merge as well, creating ripples that influence the shapes of galactic disks and the orbits of stars. Understanding these processes is key to decoding the large-scale structure of the universe and the cosmic web of filaments and voids that connect galaxies across vast expanses of space. One particularly fascinating aspect of the Hourglass galaxy is how it challenges our notions of time. The entire merging process may last a few 100 million years, an eye blink on cosmic timescales, yet unimaginably long for human civilization. When we look at ESO 593-8, we are seeing light that has traveled 500 million years to reach us. The dance we observe is already long finished. The hourglass we see today may have already collapsed into a single, massive elliptical galaxy, its two black holes perhaps merged into one. In this way, astronomy becomes an act of time travel, allowing us to witness past events unfolding across cosmic history. The study of such systems also informs our understanding of the ultimate fate of galaxies, including our own Milky Way. Astronomers predict that in about 4 billion years, the Milky Way will collide with the neighboring Andromeda galaxy in a similarly spectacular merger. While the prospect might sound apocalyptic, such cosmic events are more like grand reorganizations than cataclysms. Few stars will collide directly, and the resulting galaxy may well resemble ESO 593-8 at some stage in its evolution. Thus, the Hourglass galaxy offers a glimpse into our own galaxy's distant future, providing a natural preview of the drama yet to come. Looking closer at the heart of the Hourglass galaxy, astronomers have detected telltale signs of intense energy release near the galactic cores, regions where the merging supermassive black holes are likely feeding on surrounding matter. As gas and dust spiral inward, they heat up and emit powerful radiation across the electromagnetic spectrum, from radio waves to X-rays. These active galactic nuclei, AGN, can outshine entire galaxies, pumping out jets of relativistic particles and sculpting the galaxy's surrounding environment. Such feedback processes regulate star formation by heating or expelling gas, ultimately shaping the mass and structure of the final galaxy. The turbulent regions where the two galaxies' disks overlap are also a playground for molecular chemistry. Here, interstellar clouds rich in molecules like carbon monoxide, water, and complex organic compounds collide and mix, triggering bursts of chemical activity. Observations with powerful radio telescopes reveal vast reservoirs of cold gas, the raw material for future stars and planets, waiting in the wings to be transformed. These molecular clouds are nurseries not only for stars, but for the ingredients of planetary systems, perhaps even the precursors of life itself. One of the most remarkable features revealed in high-resolution images is the pattern of tidal tails, long, graceful streams of stars and gas flung outward by gravitational forces. These tails act as cosmic fossils, preserving the memory of past interactions and providing astronomers with a record of the collision's dynamics. By studying their shapes and motions, scientists can rewind the clock, reconstructing how the galaxies first approached each other, how they passed through one another, and how they will eventually settle into their final form. Beyond its scientific value, the Hourglass galaxy also resonates on a poetic level. It is a monument to transformation, a cosmic hourglass marking not the passing of sand, but the passage of stars through time and space. In its glowing lobes and dark dust lanes, we read a narrative of chaos giving rise to order, of death birthing new generations of stars, of gravity weaving separate worlds into one. For all its strangeness and violence, the Hourglass galaxy is a symbol of resilience and rebirth, echoing themes that run not only through astronomy, but through the human experience itself. As astronomers continue to observe the Hourglass galaxy with cutting-edge instruments, they uncover subtler details hidden within the brilliance of its larger structures. Embedded within the tidal tails are clusters of young, hot stars, many arranged in compact associations that may eventually evolve into globular clusters, the ancient, spherical star cities found orbiting massive galaxies. These newborn clusters act as cosmic time capsules, preserving a snapshot of the galaxy's violent past and offering clues about the conditions under which stars form in extreme environments. The interaction has also reshaped the galaxy's magnetic fields, stretching and twisting them like cosmic taffy. These magnetic fields influence the motion of charged particles, shaping the flow of gas and affecting where stars can form. Radio observations reveal polarized emission that maps these tangled fields, adding yet another layer of complexity to the galaxy's story. It is a reminder that galaxies are not merely collections of stars and dark matter but dynamic, magnetized ecosystems where energy and matter are constantly exchanged. The Hourglass galaxy also holds significance in the context of cosmic evolution. Interacting galaxies like ESO 593-8 are more common in the early universe, when galaxies were closer together and collisions happened more frequently. By studying local examples, astronomers gain a window into the processes that shaped the young cosmos, transforming small irregular protogalaxies into the majestic spirals and ellipticals we see today. The lessons learned here stretch across billions of years, linking the present-day universe with its fiery, chaotic past. On a human scale, it is astonishing to realize that our species has only recently developed the tools and knowledge to witness such distant marvels. Telescopes like Hubble, the Atacama Large Millimeter/Submillimeter Array, ALMA, and the James Webb Space Telescope extend our senses across unimaginable distances, allowing us to perceive and study phenomena we once only dreamed of. In doing so, they remind us that we are part of a vast, unfolding story, a tiny, conscious fragment of the cosmos striving to understand itself. The light from the Hourglass galaxy, streaming across space for 500 million years, now falls gently onto our detectors and into our minds, expanding the boundaries of our knowledge and imagination. To gaze upon it is to glimpse not just an astronomical object, but a profound connection across space and time, a reminder that we, too, are the children of cosmic collisions, born from the ashes of ancient stars. The Hourglass galaxy also serves as a remarkable testing ground for the limits of astrophysical theory. Its unique morphology, those graceful arcs and luminous lobes, challenges simulations to capture not only the gravitational ballet of billions of stars but also the behavior of gas clouds, the formation of new stars, the interplay of magnetic fields, and the influence of dark matter. To accurately reproduce such a system in a virtual universe, astrophysicists must weave together equations describing everything from fluid dynamics to relativity, all while pushing the limits of supercomputing power. Each successful simulation brings us one step closer to understanding the cosmic recipe that builds galaxies like this one. The galaxy's central supermassive black holes, though invisible to optical telescopes, exert an outsized influence. As they pull in surrounding material, they generate extreme environments near their event horizons, where matter is accelerated to nearly the speed of light and time itself slows down relative to the rest of the universe. These black holes act as both destroyers and creators. They disrupt their immediate surroundings with jets and radiation, but they also regulate the inflow of gas that can spark future waves of star formation. Some scientists even speculate that these active galactic nuclei can affect their host galaxies on scales of tens of thousands of light-years, setting the pace of their cosmic evolution. One of the most poetic truths about the Hourglass galaxy is that we are seeing it at a precise, fleeting moment in its transformation. This spectacular hourglass shape will not last forever. Over time, the two galaxies will fully coalesce, their disks will settle, their gas will redistribute, and the combined system will likely become a giant elliptical galaxy, calm on the surface but still harboring the quiet aftermath of a once tumultuous past. The hourglass will fade, but its legacy will remain written in the orbits of its stars, in the arrangement of its globular clusters, and in the whisper of its merged black hole. For the human imagination, the Hourglass galaxy offers a profound meditation on impermanence and change. It reminds us that the cosmos is not a static backdrop, but a restless, evolving canvas where every structure is a temporary arrangement of matter and energy. Even the most majestic galaxies are caught in cycles of birth, transformation, and dissolution. And as we peer outward into space, we are also looking inward, grappling with the universal rhythms of creation and decay that shape everything, from the life of stars to the arc of human civilizations. In the quiet darkness between the galaxy's two luminous lobes, astronomers detect streams of interstellar gas flowing like rivers through space. These delicate filaments bridge the cores of the merging galaxies, acting as conduits for matter and energy. As gas flows inward, it fuels not only the growth of the supermassive black holes but also triggers explosive waves of star formation in the compressed regions it passes through. These stellar nurseries flicker like cosmic beacons, their brilliance signaling the birth of massive, short-lived stars destined to burn furiously and die young, scattering heavy elements back into the galaxy. On a larger scale, the Hourglass galaxy participates in the cosmic web, the vast scaffolding of dark matter and gas that threads through the universe. Galaxies like ESO 593-8 are not isolated islands but nodes in this immense network, exchanging material with their surroundings through tidal interactions, galactic winds, and inflows of primordial gas. Over billions of years, these exchanges help enrich the intergalactic medium with metals, fueling the next generation of galaxies and shaping the chemical evolution of the cosmos itself. The hourglass shape we see today is a reminder of the profound role that gravity plays in the universe. Though it is the weakest of the fundamental forces, gravity sculpts everything on the largest scales, from the rise and fall of tides on Earth to the formation of galaxy clusters and the bending of spacetime itself. In the Hourglass galaxy, gravity's artistry is laid bare, as it draws together billions of stars, steers rivers of gas, and choreographs the cosmic dance of black holes. It is both the architect and the storyteller of this galactic merger. The light we receive from ESO 593-8 is more than just illumination, it is information, a coded message written in photons. Each photon carries the imprint of its journey, shaped by the dust it passed through, the magnetic fields it crossed, and the gravitational wells it escaped. By carefully analyzing this light, astronomers decode the history of the galaxy, extracting details about its composition, temperature, velocity, and even its past collisions. It is a profound achievement of human ingenuity that from a speck of light on a telescope sensor, we can reconstruct the life story of a galaxy 500 million light-years away. For all its scale and splendor, the Hourglass galaxy invites a sense of connection. Its story is not merely a distant spectacle, but a chapter in the shared history of the universe. The elements forged in its stars, carbon, oxygen, nitrogen, are the same elements that make up our bodies, the air we breathe, and the planets we explore. In contemplating ESO 593-8, we are reminded that we are not observers standing apart from the cosmos, but participants woven into its fabric, linked across time and space to stars and galaxies we may never touch but will always carry within us. As we continue to study the Hourglass galaxy, we uncover not only the physics of a single system, but also the universal principles that govern galaxies everywhere. The violent mergers that sculpt galaxies like ESO 593-8 are not exceptions, they are fundamental to cosmic evolution. Without collisions, galaxies would remain small, their growth stunted, their diversity limited. It is through these interactions that galaxies gain mass, trigger waves of star formation, reshape their disks, and often transform from delicate spirals into massive ellipticals. In this sense, the Hourglass galaxy stands as a cosmic chrysalis, caught in the act of metamorphosis. Within the chaos of the merger, the seeds of future order are already taking root. As the gravitational tug-of-war stabilizes, and the gas clouds either form stars or are blown away by powerful winds, the system will gradually settle into a new equilibrium. In its final form, the memory of its hourglass phase will live on, not only in its altered structure but also in its enriched chemical makeup, in the merged black hole at its center, and in the fossil record of its globular clusters. To a trained eye, the quiet elliptical galaxy it will become will still whisper of its turbulent past. Even the surrounding space bears witness to the Hourglass galaxy's story. Faint streams of stars, ejected during the merger, stretch across intergalactic space, forming stellar halos and bridges to nearby galaxies. These tidal relics are the signatures of past encounters, the fingerprints of gravity left across millions of light-years. In some cases, they may even give rise to dwarf galaxies, sculpted from the debris of the encounter. Thus, the influence of a single galactic collision ripples outward, leaving an imprint on its cosmic neighborhood. Observing ESO 593-8 also pushes the limits of our technology and imagination. To capture its full complexity, astronomers combine data from multiple wavelengths, optical, infrared, radio, ultraviolet, and X-ray, each revealing a different layer of the galaxy's anatomy. Instruments on Earth and in space work in concert, painting a multidimensional portrait of a system too vast and dynamic for any single telescope to encompass. This collaboration between human intellect and technological achievement is one of the quiet triumphs of modern astronomy, a testament to our species' relentless curiosity and creativity. For poets, philosophers, and dreamers, the Hourglass galaxy offers something even deeper, a symbol of time itself. Its luminous waste seems to measure the flow of epochs, marking the inexorable passage from youth to maturity, from chaos to calm. To gaze upon it is to be reminded that all things are in motion, that transformation is the rule, not the exception. It stirs a sense of awe not only for the beauty of the universe, but also for its profound capacity to change, to evolve, to renew itself in endless cycles of birth and rebirth. In the distant future, long after the hourglass shape has faded, the merged galaxy will drift quietly through space, a giant elliptical glowing with the combined light of billions of stars. But the legacy of the Hourglass galaxy will not end there. The stars born in the fires of the merger will live out their lifespans, some ending as white dwarfs, others as neutron stars or black holes. The heaviest of them will explode as supernovae, scattering heavy elements, gold, platinum, uranium, into interstellar space. These elements will seed future generations of stars and planets, continuing the great cosmic cycle of enrichment and creation. In a universe governed by entropy, where order tends to break down over time, galaxies like ESO 593-8 are paradoxically places of renewal. Even as old stars fade and structures collide, new patterns emerge, new stars blaze to life, and new worlds take shape. If life exists elsewhere in the cosmos, perhaps on planets circling stars born in such mergers, it owes its existence to the titanic processes we now observe with our telescopes. To study the Hourglass galaxy is, in some sense, to study the origins of potential life across the universe. There's also something deeply human in the act of watching such distant phenomena. Across a gulf of space and time, we project our questions, our hopes, our longing for understanding onto these luminous shapes in the sky. We marvel at their beauty, we decode their physics, and we weave their stories into our own. The Hourglass galaxy is not merely a collection of stars and gas, it is a mirror in which we glimpse our own impermanence, our capacity for change, and our hunger for meaning. Technologically, the study of galaxies like ESO 593-8 prepares us for the next era of discovery. As instruments like the James Webb Space Telescope and the Vera C. Rubin Observatory come online, astronomers will probe even fainter and more distant systems, tracing the entire history of galaxy formation from the earliest epochs of the universe. The Hourglass galaxy is one piece in a vast cosmic puzzle, a clue that helps us map the journey from primordial hydrogen clouds to the richly structured universe we inhabit today. Perhaps the most profound realization is that the universe is never finished. It is an ongoing act of becoming, a symphony without a final note. The Hourglass galaxy, in its transient splendor, invites us to embrace that truth, to see change not as loss, but as evolution, to recognize that even in the grandest scales, renewal is always underway. As the Hourglass galaxy drifts through its transformational journey, it becomes part of a lineage stretching back to the earliest epochs of the cosmos. Long before its hourglass form emerged, the matter composing it was born in the aftermath of the Big Bang, shaped by quantum fluctuations and gathered into dark matter halos that would one day become galaxies. The stars we see shining today were forged in waves of cosmic assembly stretching over billions of years, some in gentle accretion, others in violent mergers like the one we now observe. Even as we study ESO 593-8 from 500 million light-years away, we are fundamentally connected to it. The same universal laws that sculpt its majestic arcs and tidal tails shape our own Milky Way. The same gravitational pull that stirs its black holes holds our solar system in its galactic orbit. The same heavy elements cast into space by its supernovae were once scattered by the ancestors of our Sun. To witness the Hourglass galaxy is to see, in some sense, a reflection of our own past and perhaps a glimpse of our far future. For the Milky Way, this future will likely echo the drama of ESO 593-8. When we eventually merge with the Andromeda galaxy, the night sky will change over eons, with arcs of stars stretching across the heavens and new stars bursting to life where clouds of gas collide. Earth may be long gone by then, but the same physics, the same beauty, will unfold across the cosmos, echoing the patterns we now admire in the Hourglass galaxy. In this way, the study of galaxies becomes an exploration not only of the external universe but also of ourselves, of our origins, our place in the cosmic tapestry, and the profound interconnections between matter, energy, space, and time. Each photon of light we capture is a message from the past, a reminder that the universe is alive with memory, recording its own history in patterns of light and motion. And so the Hourglass galaxy spins on, its luminous lobes glowing across the void, its black holes entwining in their slow dance, its newborn stars lighting up the darkness. It invites us to marvel, to question, to reach across the depths of space with our minds and instruments, and to remember that we, too, are part of this great cosmic story, temporary, changing, yet enduring in ways we are only beginning to understand. As the Hourglass galaxy continues its long transformation, it becomes a living monument to the power of cosmic time. For all its present drama, the streams of stars, the glowing dust lanes, the erupting stellar nurseries, it is still only a passing phase in the life of a galaxy. Eventually, the turmoil will subside. The intense starburst activity will wind down as the gas reservoirs are depleted, the chaotic orbits of stars will relax into smoother, more settled paths, and the merged black holes will sink quietly into the center of the newly unified galaxy, anchoring it with their invisible mass. But the memory of the merger will persist. Future astronomers, perhaps on worlds circling second- or third-generation stars born from the debris of the collision, may study the diffuse halos of stars, the altered chemical signatures, the faint ripples in the galaxy's outskirts, and piece together the story of how two once separate systems became one. In this way, galaxies carry their own archaeological records, fossilized in their structure, awaiting discovery across epochs. And the Hourglass galaxy's story doesn't end within its own bounds. The heavy elements created in its most massive stars, elements forged under crushing pressure and released in supernova explosions, will enrich the surrounding intergalactic medium. Over cosmic time, some of this material may drift into new galaxies, seed new stars, form rocky planets, or even contribute to the chemistry of life. What we witness now, then, is not just an isolated event, but a ripple in a vast, interconnected web of cosmic evolution. In observing such galaxies, we are reminded of the incredible range of scales the universe contains. On one level, we see the dance of galaxies measured in millions of light-years; on another, we glimpse the forging of elements inside stars only a few million kilometers across. Yet from the largest to the smallest, all are bound by the same elegant physical laws. This continuity across scales is one of the profound beauties of the cosmos, inviting a sense of unity and wonder that transcends our everyday experience. For all its violence, the Hourglass galaxy is a place of creation as much as destruction. It is a forge of stars, a sculptor of form, a builder of complexity. It reminds us that the universe, while shaped by entropy, also harbors local bursts of order, where gravity, radiation, and chemistry weave temporary masterpieces into the tapestry of space-time. And for us, as observers on a small rocky planet orbiting an ordinary star in a spiral galaxy, the Hourglass galaxy offers something more than data points and measurements. It offers perspective. It shows us that we live in a universe of endless change, where every galaxy, every star, every atom is part of an ongoing journey. To look upon ESO 593-8 is to be reminded that the universe is not a finished work, but a story still unfolding, and that we, too, are threads in that grand cosmic narrative. In the silence of space, the Hourglass galaxy continues its grand, unhurried transformation, a cosmic performance unfolding on a stage so vast that even light takes 500 million years to carry the news of its spectacle to our tiny corner of the universe. As we observe it from afar, we become part of its audience, and in doing so, we anchor its story within our own. The merging galaxies within ESO 593-8 are not simply victims of gravitational inevitability, they are participants in a process that has shaped the architecture of the cosmos. Without such collisions, the universe would lack its giant ellipticals, its sprawling galactic clusters, and the rich chemical complexity needed to form planetary systems and, eventually, life. In fact, it is this very dynamic interplay of matter, energy, and time that has made the universe a place capable of evolving complexity, from atoms to living beings capable of wondering at it all. As we continue to study galaxies like ESO 593-8, we find that they also serve as benchmarks across cosmic time. They help calibrate our models of how fast galaxies form, how often they collide, and how dark matter behaves during such events. Observing the Hourglass galaxy thus sharpens our understanding of the universe's past and refines our predictions about its future. It feeds into simulations that tell us how galaxies like our Milky Way will look billions of years from now, how black holes shape their environments, and how the cosmic web grows more intricate over time. In the delicate glow of the Hourglass galaxy's lobes, there is a quiet truth that reaches beyond science. It whispers of impermanence, of beauty born in chaos, of the universe's restless nature. It reminds us that even when stars collide, something wondrous can emerge, that from disarray comes new form, that from endings come beginnings. In this sense, ESO 593-8 is not just an object of study, it is a cosmic poem written in stars and gas, a reminder that the universe itself is a storyteller, and we are privileged to read its words across time and space. On clear nights, when we lift our gaze toward the sky, we connect with galaxies like the Hourglass, not just with our eyes, but with a deep, almost instinctive sense of belonging. For all its distance, for all its alien grandeur, the Hourglass galaxy is part of our shared history, a monument to the restless creativity of the cosmos that gave rise to stars, planets, and ultimately to us. It is a reminder that, against the vast canvas of time, we too are luminous, if only for a moment. And so, the Hourglass galaxy drifts onward through the immensity of space, its fate sealed yet its journey far from over. Though its hourglass shape will eventually smooth into the rounded form of an elliptical galaxy, its legacy will ripple outward for eons. The stars it births today will orbit in intricate, graceful paths, some perhaps with planetary systems of their own, circling second-generation suns that trace their origins to the merger's furious, creative heart. There is a profound humility in realizing that we, the observers, are made of the same elements that burn in those distant stars. The iron in our blood, the calcium in our bones, the carbon that shapes the molecules of life, all were forged in the furnaces of ancient stars, in galaxies that once collided, merged, and transformed, just as ESO 593-8 does now. When we gaze at the Hourglass galaxy, we are in a sense looking into a mirror reflecting not just the faraway past, but our own cosmic ancestry. With every photon captured, with every spectrum analyzed, we peel back the layers of the universe's history. The Hourglass galaxy is but one chapter in this immense story, yet it holds within it all the elements of the cosmic epic: birth, death, chaos, beauty, destruction, renewal. For astronomers, it is a treasure trove of data; for poets, a source of endless metaphor; for philosophers, a reminder of the fleeting and transformative nature of all things. Even now, new generations of telescopes and instruments are being prepared to take deeper, sharper looks at such galaxies. They will peer into the infrared glow of newborn stars, map the cold molecular gas waiting to collapse into new systems, and measure the invisible dark matter halos that cradle the visible galaxy. With each advance, we draw closer to a unified understanding of how the universe builds its grandest structures from the simplest beginnings. But beyond the science, beyond the theories and models, the Hourglass Galaxy continues to speak in a language older than words. It speaks of time's arrow, of the dance between order and chaos, of the inexhaustible creativity of the cosmos. It invites us not only to study, but to wonder, not only to calculate, but to feel awe, not only to reach outward, but to reflect inward. And as long as we keep looking up, as long as we keep asking questions, the Hourglass Galaxy will remain a companion in our exploration, a luminous testament across the void that we, too, are part of this vast, evolving universe. The light of the Hourglass Galaxy will continue to pour across space for millions of years, crossing the abyss between galaxies, untouched by time, until it falls upon the detectors of worlds that have yet to form. Perhaps one day, eyes unlike ours, whether biological or machine, will also lift toward this galaxy and study its remnants, trying to reconstruct its story as we do now. And perhaps they too will feel the same sense of wonder, the same realization that they are connected to a cosmos vast beyond measure yet intimate in its shared ingredients and history. As the supermassive black holes at its center spiral toward each other, they will radiate gravitational waves, sending ripples through the very fabric of spacetime. These waves will ripple outward at light speed, stretching and squeezing space itself, carrying the final signature of the merger to the universe beyond. Instruments like LIGO and future space-based observatories may one day detect such echoes, adding yet another layer to the cosmic dialogue between light, gravity, and matter. Meanwhile, the once separate populations of stars, gas, and dust will continue to mix, blending their distinct chemical signatures. Over time, the galaxy's stellar populations will age, its brilliant blue star-forming regions will fade to gold, and it will become a calmer, redder, more massive system. But within its depths, relics of its turbulent youth, dense star clusters, streams of displaced stars, pockets of gas enriched by supernovae, will preserve the memory of its hourglass phase. For humanity, the Hourglass Galaxy stands as both a beacon and a mirror. It shows us the immensity of time, the power of natural forces we can scarcely grasp, and the beauty that emerges from collision and transformation. It challenges us to keep refining our tools, deepening our understanding, and nurturing our sense of wonder. It reminds us that we are cosmic beings, shaped by the same laws that govern galaxies, connected by the same elements, fleeting but radiant in the grand scheme of things. And so the hourglass turns, its sands made of stars, its narrow waist a passage between past and future, its wings stretched across light years. To watch it is to participate in the ancient, ongoing story of the universe, the story of matter that became complexity, of chaos that became form, of dust and gravity that learned, against all odds, to shine. Even as the Hourglass Galaxy completes its slow metamorphosis, its story ripples outward, woven into the larger history of the universe. The merging of its black holes will not only shape its center but contribute to the ever-growing population of supermassive black holes that anchor galaxies across the cosmos. These objects, once thought to be mere destructive engines, now appear as central players in regulating galaxy growth, moderating star formation, and sculpting the flow of matter on cosmic scales. The Hourglass Galaxy is thus not an isolated spectacle, it is part of a vast network of events shaping the architecture of the universe itself. In the deep future, when the galaxy has long since settled, its brightest stars will have exhausted their fuel, leaving behind dim remnants, white dwarfs cooling in the dark, neutron stars whispering through space with faint pulses of radiation, and black holes hidden in the shadows. Yet even in this aging system, time will continue its work. Stars will occasionally pass close enough to disrupt one another, planetary systems will slowly rearrange, and the great central black hole will persist as a silent sentinel at the galaxy's heart. And far beyond, the universe itself will keep changing. The galaxies around ESO 593-8 will move farther apart, driven by the accelerating expansion of space. The cosmic microwave background, now a faint afterglow of the Big Bang, will continue to cool and fade. But even in that future, the fingerprints of the Hourglass galaxy will endure, written into the distribution of matter, the chemical makeup of stars, and the silent waves traveling through spacetime. For us on Earth, the Hourglass galaxy carries another quiet gift: perspective. It invites us to step outside the narrow window of human time and glimpse the universe as it truly is, vast, evolving, ancient, and creative beyond comprehension. It reminds us that our struggles and triumphs, our fears and hopes, exist against the backdrop of a cosmos that is at once indifferent and magnificent. And in recognizing this, we gain something rare and precious, a sense of belonging to something far greater than ourselves. Long after our own civilization has passed into history, long after Earth has changed beyond recognition, the light of ESO 593-8 will continue on its journey, a testament to the restless energy of a universe forever in motion. It will continue to inspire those who look up, to challenge those who seek to understand, and to remind all who witness it that beauty, in the universe, often arises from the most unexpected collisions. Somewhere, countless eons from now, the light now leaving the Hourglass galaxy will brush past new worlds, perhaps worlds with beings as curious and searching as we are, beings who will look to the skies and wonder. To them, the hourglass shape may have faded, the merger completed, the once turbulent galaxy now a massive, settled elliptical, yet its light will still carry the memory of a time when two galaxies danced and collided, when chaos birthed brilliance, when the universe displayed its ceaseless creativity. In a sense, the Hourglass galaxy is a time machine. When we observe it, we are not seeing it as it is today, but as it was 500 million years ago. We are witnesses to a moment frozen in the flow of light, a message that began its journey long before humans walked the earth, before the continents took their modern shapes, before even the earliest forms of complex life arose in Earth's oceans. It is humbling to realize that the universe is full of such messages, ancient and patient, waiting for someone, somewhere, to look up and listen. The more we study galaxies like ESO 593-8, the more we understand that destruction and creation are intertwined at every level. Collisions like these do not merely tear galaxies apart, they forge new stars, mix and redistribute elements, reshape galactic architecture, and set the stage for new planetary systems. The violence is not senseless, it is the engine of transformation. And so the Hourglass galaxy becomes a symbol, not just of galactic evolution, but of the universe's deep capacity for renewal, for turning even upheaval into opportunity. And perhaps that is why the sight of the Hourglass galaxy resonates so deeply with us. On some level, we recognize our own story in it, the tension between order and chaos, the inevitability of change, the possibility of rebirth. We, too, are shaped by forces beyond our control, by time, by chance, by history, and yet within that shaping, we find room for growth, for creativity, for wonder. As telescopes continue to sharpen their gaze, as simulations become more sophisticated, as our understanding deepens, the Hourglass galaxy will reveal still more of its secrets. But no matter how much we come to know, it will always retain its mystery, always whisper of a cosmos more vast, more intricate, and more beautiful than we can ever fully grasp. And so, across time and space, the Hourglass galaxy continues to shine, a monument to impermanence, a celebration of creation, a light in the dark that speaks to all who are willing to listen. Even across unimaginable distances, the Hourglass galaxy connects us to the oldest and most enduring truths of the cosmos. It reminds us that the universe is not a silent void but a place of constant motion, of collisions and mergers, of collapse and rebirth. Each swirl of its luminous arms, each filament of gas stretched between its merging cores, speaks to the profound power of gravity and time to sculpt beauty out of chaos. As our instruments grow more sensitive, we may one day trace the faintest echoes of its past, the precise velocities of stars thrown out into intergalactic space, the chemical fingerprints left behind in ancient star clusters, the gravitational waves still rippling through spacetime. And as we push ever farther into the depths of the universe, we will likely find countless other galaxies frozen in similar moments of transformation, each one a variation on the same grand theme of cosmic evolution. But no matter how many galaxies we catalog, how many simulations we run, or how deeply we probe the mechanics of mergers, something about the sight of the Hourglass galaxy will always transcend data. It will always stir a quiet sense of awe, not just because of its scale or strangeness, but because it invites us to confront the fundamental nature of change. In its glowing lobes and dark lanes, in its tangle of stars and gas, we see written the universal story, that nothing lasts, and yet from every ending, something new emerges. On Earth, under the night sky, that light continues to arrive, photon by photon, whispering its billion-year-old tale into our instruments and imaginations. It crosses the void to find us here, momentary creatures on a small planet, daring to wonder what lies beyond, daring to believe that by understanding the stars, we understand something essential about ourselves. Someday, perhaps, we will send explorers, robotic or living, across interstellar distances, and they may pass near the remnants of ESO 593-8, observing up close the marks of its ancient collision. Perhaps they will walk on worlds formed from its dispersed gas, or orbit stars that once were flung from its heart. And in doing so, they will carry forward the same questions we ask today, propelled by the same human drive to know, to reach, to connect. Until then, we watch from afar, grateful that in this brief window of existence we have been given the tools and the curiosity to glimpse such wonders. The Hourglass galaxy turns, the stars blaze and fall, the black holes spiral and merge, and through it all, we listen, we learn, and we marvel. Even as the Hourglass galaxy drifts farther into the depths of cosmic time, its light continues to bind us to a universe far older and more intricate than we can easily comprehend. Each time we point our telescopes toward ESO 593-8, we become part of a timeless dialogue between matter and mind, between the vastness of space and the spark of human consciousness that seeks to understand it. As our instruments evolve, we will one day measure not just the large-scale motions of its stars and gas, but the subtle interplay of individual stars, the faint ripples left by past supernovae, the cold, silent clouds waiting to ignite new generations of suns. We will uncover the orbits of ancient star clusters thrown into the galaxy's halo, we will map the faint streams of stars pulled into intergalactic space, and we will read the chemical signatures of the elements born in its most violent moments. With each new detail, the picture becomes clearer, yet paradoxically, the sense of wonder deepens, because with each new answer, the universe offers even greater and more complex questions. What the Hourglass Galaxy ultimately gives us is perspective, a chance to see our place in a cosmos governed by the same physical laws, touched by the same processes, shaped by the same ancient forces. In its vast, majestic unfolding, we glimpse the shared heritage of all things, that we, too, are the product of cosmic collisions, of stellar alchemy, of the restless creativity of time and gravity. The very atoms that make us possible were forged in galaxies like this one, and the impulse that drives us to study it is itself part of the same evolutionary chain that began with hydrogen clouds collapsing into the first stars. In its hourglass shape, there is an almost symbolic beauty, a reminder that time is both fleeting and cyclical, that galaxies, like living beings, have stages of birth, transformation, and quiet maturity. To witness the Hourglass Galaxy is to step into a moment between past and future, to see creation in motion, to watch the universe reshaping itself before our eyes. Perhaps the most profound gift of ESO 593-8 is this: it teaches us that change is not merely loss, but possibility. That in the heart of collision, new worlds are born. That through destruction, the cosmos finds new forms of beauty. And that in seeking to understand these distant processes, we are, in a small but meaningful way, affirming our place within them, as witnesses, as explorers, and as children of the stars. And so, the Hourglass Galaxy continues its slow, luminous drift through the cosmos, a monument to impermanence, a celebration of creation, and a quiet reminder that nothing in the universe stands still. Long after its hourglass form has faded and its turbulent heart has settled into calm, its legacy will live on, in the stars it birthed, in the elements it scattered, in the unseen ripples it sent through space and time. For us, it remains a beacon in the dark, a symbol of the universe's endless unfolding, a reflection of its restless beauty, and an invitation to wonder. To gaze upon ESO 593-8 is to touch a truth both humbling and profound, that across light years and eons, we are connected to the great cosmic story, woven from the same threads of matter and energy, and forever drawn to the stars from which we came.